Today we explain the concept of a function. A function is shown by an equation written as y equals f of x, where x is the input, called the domain of f, and y is the output, called the range of f. We can think of a function as a machine that takes each x and produces an output y. We call x the independent variable. Any the dependent variable, because the value of y depends on the value of x. We can also represent a function using a diagram. We have a set of x values, and for each value of x, there is exactly one value of y. Each x maps to only one y. This is how a function is defined. We can also represent a function using a table. For example, if we have values, x equals a gives y equals d, x equals b gives y equals e. Then we can say f of a equals d, which means that when x is a, the value of the function is d. Similarly, f of b equals e. We can also represent a function using a graph. The horizontal line shows the x values, and the vertical line shows the y values. The curve on the graph represents the function. For example, when x is a, the corresponding y value is d, so f of a equals d. Now, not every equation is a function. Suppose for x equals a, we have f of a equals d, and also f of a equals e. This means one input has two outputs. Then, the same value of x corresponds to two different values of y, which is not allowed in a function. Then f is not a function. We can also see this on a graph. If for a single value of x there are 2 points on the graph, 2 y values, then f is not a function. This idea is tested using the vertical line test. If a vertical line intersects the graph at more than one point, then the graph does not represent a function. If it intersects at only one point for every x, then it is a function.